The story of the comet's origin begins 4.6 billion years ago. Our solar system is in the midst of a fitful birth. In the center, a cloud of gas and dust begins to contract into an immense disk. The disk's powerful gravity sucks masses of matter inwards. Pressures and temperatures soar until the enormous dense ball ignites, its gases and matter imploding in nuclear fusion. A star, our Sun, is born. Left to orbit the newborn Sun is a fog of debris. The fragments careen into one another and clump together into celestial dust balls. Over millions of years, these monster clumps grow larger as they orbit the Sun, until they form an array of planets, including our Earth. But some dust balls, future comets, do not merge and condense into planets. 1 billion or more slowly gravitate to an orbit between Neptune and Pluto, a region called the Kuiper Belt. Trillions of others are exiled partway to the next star, to a nebulous realm called the Oort cloud. Hurled outward by the gravitational fields of large planets like Jupiter, they have elliptical orbits that vary greatly.
You've got the Kuiper Belt region of comets, and they're mostly compressed into a plate-like distribution. But in the Oort cloud, which is 1,000 times further out, they're in a veritable cloud. So you've got objects in this kind of an orbit, this kind of an orbit, that kind of an orbit. They're coming in from the outermost edge of the solar system.
Amazingly, astronomers did not confirm the Kuiper Belt's existence until 1992, even though it is part of our solar system. Today, they believe the Kuiper Belt is the outer range of comets with the most stable orbits, those that enter the inner solar system every 3 to 200 years. The best known of these, Halley, returns every 76. But it is the second region, the Oort cloud, 2 light-years away, that troubles scientists most. Scientists believe an occasional disruption, like a change in a star's gravitational field, will eject a comet from this cloud. It can then fall under the gravitational pull of our own Sun and start a journey towards our inner solar system, taking thousands of years. Scientists have no way to predict when these comets will appear, and they can come from any direction. One may already be on a collision course with Earth. For these fragile outcasts, every journey into the inner solar system is fraught with peril. Some will lose their icy payload and become dormant as the Sun burns off their gases. Some will break apart as their icy glue melts in the solar heat. The fragments may continue to circle the Sun, appearing to us as meteor showers or shooting stars. Some comets will enter Jupiter's orbit, drawn by its enormous gravitational field. The giant planet then catapults the invaders back out of the solar system. But some will run full tilt into another heavenly body.
Composed of rock, gases, dust, and ice, comets are known to break apart when they encounter the gravitational pull of large objects like planets. In July of 1992, the Hubble Space Telescope recorded exactly this scenario. As Comet Shoemaker-Levy 9 hurtled past Jupiter, the planet's immense gravitational pull tore the comet apart.
Comet Shoemaker-Levy 9 broke up into several dozen fragments, the most massive of which created an explosion equivalent to 6 million megatons of TNT. Now, the biggest bomb ever made on Earth is the Tsar Bomba by the Soviet Union, which was 50 megatons. A single impact from Shoemaker-Levy 9 was 100,000 times more powerful.
Comets are known to have tails, the visible effect of two byproducts: dust reflecting sunlight and glowing ionized gases roaring off the back like jet contrails.
Interestingly enough, you can actually have what's called an anti-tail, where from our point of view, it looks like the tail of the comets are actually pointing in two totally different directions. So as solar radiation streams off of our sun, it tends to make the material that's evaporating off of the comet appear to recede away from the sun.
As seen from certain spots on the Earth, the dust tail can sometimes curve around so that it appears to point in the opposite direction.
So observers on Earth would see an object in which it looked like there was a head with a headdress or a horn coming out of its head. In North American mythology, South American mythology, it's a serpent with a horn on its head. In Hindu, it's a fish with a giant horn on its head.
When a comet or an asteroid hits the Earth's atmosphere, it actually creates a wake, very much like the wake in front of a boat. And that shock wave, the shocked air, gets to super high temperatures and it radiates. It radiates light and infrared radiation, and then that heats up the comet or asteroid and causes it to vaporize.
Even a smaller Tunguska-sized meteor, around 200 or more feet in diameter, can produce an airburst with 1,000 times more energy than the atomic bomb dropped on Hiroshima. Some 13,000 years before the Tunguska impact, the Clovis comet could have delivered a similar airburst. But the North American landscape would have long ago swallowed all traces. Whether it was a ground-impacting comet, an airburst, or neither one, this climatic event and its effect on the Clovis culture remain a hotly debated topic. But solving the mystery is crucial, since the same thing could happen today with little warning.
If a comet did explode in the planet's atmosphere 13,000 years ago, the evidence has to exist. The first place scientists looked was in the geological record. In more than 20 different Clovis archaeological sites across North America, scientists have found something unusual. A 2-inch layer which they have dubbed a black mat. The unusual sediment dates to approximately 13,000 years ago, suggesting this layer could be tied to the extinction event. Beneath the black mat, mammoth bones and artifacts of the prehistoric Clovis people are found. Just above the black mat layer, few signs of humans or animals.
The telltale signs we do have at that boundary, at that time, these hints that something went on, and these hints include fine debris that was spread over the area. There was a layer where there were largely where all the mammals disappeared, and then there was this massive burning.
Could there also be physical evidence of a comet in the black mat? Scientists believe that if a comet were responsible for devastating North America, it would leave behind an interstellar trail, similar to the famous KT layer, a layer of clay that proved a massive asteroid slammed into the Earth 65 million years ago, killing the dinosaurs.
The KT boundary, the Cretaceous-Tertiary boundary, this was a layer that was found at a certain horizon where there was a sudden dying across here, 75% of species. They discovered this big giant spike of iridium, and not just iridium, it was other types of elements that are associated with iridium that tells you that this had to be from a cosmic abundance, that is something that came from space.
In 2005, scientists gathered at a Clovis site known as Topper in South Carolina, looking for evidence of a comet. Professor Albert Goodyear was lead archaeologist at the site.
This is the approximate location sampled here in 2005. A large number of examples of the magnetized particles that they think came from literally out of space, and they were very clearly associated with the Clovis layer. Later on in the laboratory, they found high concentrations of iridium, nickel, and some sort of carbonized glass. Topper has trillions and trillions of nanodiamonds. The geophysicists regard nanodiamonds as sort of a high probability extraterrestrial element.
Just like with the KT layer, scientists now had proof that a comet or asteroid had played a role in the extinction of life in North America. But unlike 65 million years ago, when an asteroid left an enormous impact crater in the Yucatan Peninsula, there was no crater tied to an event in North America 13,000 years ago. Scientists believe the Clovis comet must have exploded in midair, just like the Tunguska comet of 1908.
When you have an impact, you're transferring all that energy of motion and you're converting it into energy of heat. It's still coming in as it flies through the atmosphere. So we're now dealing with the equivalent of a fire hose coming down on Earth at the same time we're having a shock wave traveling across the surface.
While it's unlikely a cometary explosion alone could have destroyed the continent, perhaps the aftermath of the explosion could. Was there also evidence of what happened after the explosion in the black mat layer? Professor Luann Becker of Johns Hopkins University studied samples taken from sites across the continent, searching for clues that a massive catastrophic event had taken place after the explosion. Samples taken from Clovis sites from California to the Carolinas all revealed evidence of soot. The presence of soot in each of these locations suggests that massive fires must have taken place right after the explosion and possibly swept across the continent.
I think there was significant fires at this event. Everywhere we looked, there's evidence for charcoal and fire in the form of what we call soot. This type of material only happens when you have huge firestorms.
Fiery fragments could certainly have set portions of the continent on fire, but could those fires have spread 3,000 miles and engulfed the entire continent?
If there were ever some sort of circumstance that led to giant wildfires spreading across all of North America, it's almost inconceivable how terrifying that would be for any population that was there.
Could wildfires really have scorched an entire continent, wiping out a civilization and driving many species into extinction? When the storms finally died down, the Clovis culture was nearly extinct, and certain species of animals would never be seen again. And in some instances, the animals that did survive would never be the same again. The bison has become an icon of the American plains, but these powerful animals may actually be a smaller version of a much larger ancestor.
The modern bison does not seem to exist in the Ice Age fossil record, and that's been curious because the modern bison seems to appear at a later time. The older ones have much longer horns.
It's possible today's bison could be some sort of genetic mutation of the ancient bison. And for some reason, these smaller bison survived the storm, passing on their genes, while the traits of their larger relatives were lost.
There could have been a genetic bottleneck, which is something that occurs when populations are brought to very low numbers. And in situations like that, quite profound changes can happen because the gene pool, as it were, has been so much reduced.
created one of the most lethal extinction events in the history of our planet. The aftermath of the comet's dust storm may have reached around the globe with devastating implications.
That changes the climate, it changes the ecosystem. What we're talking about now is something on a big, broader scale. When you darken good portions of the Earth for weeks at a time, it eventually will have its effect on all parts of the ecosystem.
The amount of soot being thrown into the air might have had global consequences for how much it might have cooled the Earth during some of this time. Even people who'd be living far, far away from the site of this comet impact could still be affected by it because of the amount of dust that would be thrown up into the air. That dust would spread around the Earth in many cases, and it would shut out their sun. They would suddenly find temperatures plunging. It would be a terrifying experience.
Globally, the amount of dust and soot mixing in the atmosphere might have blocked out the sun, causing temperatures to drop.
You're going to block sunlight, you're going to cause some cooling, you're going to change the weather patterns and potentially cause thunderstorms, and the whole dynamic is changed by the presence of the dust particles. And so that changes the climate, changes the ecosystem.
But the most far-reaching consequence of this dust storm may have been triggered when the storm died down. Once the dust and soot mixture fell out of the atmosphere, vast quantities of it would have come to rest on a massive ice sheet that covered nearly all of Canada.
When you accrete a lot of dust into the atmosphere, eventually it's going to make its way to the ice sheet. And so you're going to go from what is a white ice sheet to parts of the ice sheet that are going to be covered with dark material. And that's going to change the response of sunlight. It could cause some significant melting.
As the darkened ice sheet increased absorption of sunlight, it began melting at an accelerated rate. The amount of glacial meltwater flowing into the ocean would have been greater than all the fresh water in the world's modern lakes, creating the potential for climatic disaster.
If you were to release tens of thousands of gallons of fresh water into the Atlantic Ocean, like we think may have happened, this would change the whole circulation of the oceans.
This huge amount of water pouring into the world's oceans would have disrupted the currents and sent temperatures plunging by 5 to 10 degrees across North America and Europe, triggering an ice age. This ice age lasted more than 1,000 years, as glaciers crept across the landscape, devouring forests. Global temperatures dropped to freezing levels. The food chain became disrupted. The human population around the world plunged.
Clearly there was an event that was a significant event that affected life, especially in North America and Northern Europe. And we see that in the biologic record, we see it in the climate record, we see it in the oceanographic record. I mean, we even see it in the ice cores.
The idea that the Clovis comet killed off nearly all life in North America and triggered a global ice age has been met with some skepticism.
This is not a slam dunk case, and I think everybody acknowledges this. But as a hypothesis that's testable, we've got all the elements of saying there was change. Where we see debris, we know that there's a black mat indicating a great dying. But all these are only indicating the fact that we had change, that is a climate change. So the issue is what caused the climate change and what those processes are.
see from multiple independent lines of evidence is that abrupt climate change is underway. It has been referred to as the hockey stick, and that's because the shape is kind of steady and flat, and then it just takes off. And so we're riding up the blade on that hockey stick.
The climate has always warmed and cooled naturally. What's going on now, why now is different, is the rate of warming is so much faster.